Okay, we're back together for part 2 of Unit 4, Lesson 2. I want to pick up with example F. So, example F looks like this. We have sine of x, tangent of x equals sine of x. Now, if we were in the classroom, I would be asking you guys if I should divide both sides by sine of x. And I'm hoping that a good number of you would say, no, Miss Scribble, we cannot divide by sine of x, because if we divide by sine of x, then we very possibly might lose a solution or two to this equation. So what we would do is we would, like in example C, we would subtract sine of x over, excuse me, and this would be sine of x times tangent of x minus sine of x equals 0. And at this point, I would factor out a sine of x, which leaves me with tangent of x minus 1 equals 0. So now I have sine of x times tangent of x minus 1. This is a product of two factors. Set each factor equal to 0. That would be sine of x equals 0. I would then have tangent of x minus 1 equals 0. And then add the 1 over. And now let's find the angles that have a sine value of 0 and a tangent value of 1. So, hopefully, let's see, we have 1, 0, 0, 1, negative 1, 0, 0, negative 1. Sine of x is 0 at 0, at pi, and I'm going to go ahead and include 2 pi. Because remember, in the directions, we want to find all the angles for x that are between 0 and 2 pi, including those. So we have 3 angles that have a sine value of 0. And then hopefully you remember that the angle that has a tangent value of positive 1 is the pi over 4 family. So x will be equal to pi over 4. And then in quadrant 3, the pi over 4 angle is 5 pi over 4, and that is the angle where tangent is positive 1 as well. Okay, so that was F. Now looking at G, example G. Now, example G, we have sine of x plus cosine of x equals 0. I'm going to talk about this from a couple of different perspectives. If I were to, let's say, subtract cosine over, I would have sine of x equals negative cosine of x. So at this point, we could simply think about this expression and then think about what angles on our circle, or what angles between 0 and 2 pi have a sine value that is the opposite of the cosine value. So what would that kind of look like? Well, first of all, think about the angle measures where sine and cosine have the same value. So that would be pi over 4. Remember, pi over 4 has the ordered pair square root of 2 over 2, square root of 2 over 2. So the x value, or the angle measure where sine and cosine would have opposite values, would be the pi over 4 family, but it would be 3 pi over 4. And the angle in quadrant 4, which is 5 pi over 4. That's not 5 pi over 4. That should be 7 pi over 4. I knew something didn't sound right. So, quadrant 2, 3 pi over 4. Quadrant 4, 7 pi over 4. So that's one way to approach this. But, okay, so let's think about this from a different perspective. What if I what if I were to divide both sides by negative cosine? No, not even negative cosine. What if I were to divide both sides by cosine? But Miss Gribble, you said we couldn't divide by cosine. Well, sometimes we can. Let me explain why we can do that here, but should not do that anywhere else. So let's think about sine of x over cosine of x. What does sine of x over cosine of x equal? Well, sine of x over cosine of x is equal to tangent of x. So if I replace sine of x over cosine of x with something that is equivalent to that, such as tangent of x, that is going to enable us to be able, well, it's not to enable us, but because I've replaced tangent of x with something equivalent, because these two are equivalent, I'm not going to lose any possible answers. So now cosine of, or tangent of x equals -1. Hopefully you're thinking pi over 4, because at pi over 4 tangent is 1, but at 3 pi over 4 and 7 pi over 4 tangent is -1. So 3 pi over 4 and 7 pi over 4. So these two, you'll notice that we get the same answers kind of no matter which way we look at it. But I want you to understand why in this scenario we could divide by cosine. When I divide both sides by cosine, I get sine over cosine, which is equivalent to tangent of x. So I'm replacing sine of x over cosine of x with something that it's equivalent to. So I'm not changing the value of it. All right, so that's G. Now let's look at E. Let me see if I can scoop this out some. Okay, so now let's look at example E. So example E, we have sine squared x equals 3 times cosine squared x. So as I look at this, and I look at the example that I have provided, or the work that I've provided in your notes, what I started out with was I said, let's get sine squared x. There's an identity that I can replace or use that involves cosine squared. And so what I've done is I'm replacing sine squared x with 1 minus cosine squared x equals 3 cosine squared x. By replacing sine squared x with 1 minus cosine squared x, what that's allowing me to do is have the equation in all the same trig functions. Okay, it's all just now in terms of cosine instead of cosine and sine. And remember, I can do this. I can use 1 minus cosine squared x because sine squared x and 1 minus cosine squared x are equivalent based on our identities. So if now my equation is all in terms of cosine, then I'm going to get my cosine terms on the same side. So I'm going to add cosine of x, cosine squared x to the other side, and that's going to give me 1 equals 4 cosine squared x. Now to get cosine of x or cosine squared x by itself, divide by 4, and I get 1/4 equals cosine squared x. To undo, well, let me remind you that cosine squared x is the same thing as cosine of x squared. So now if I take the square root of both sides, I get cosine of x equals, the square root of 1/4 is 1/2. And because I put the radical in there, my value should be positive and negative 1/2. So now let's find the angle whose family, let's find the family of angles that have a cosine value of positive and negative 1/2. So that would be pi over 3. So x would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So cosine has a positive 1/2 or a negative 1/2 value in all 4 quadrants. All right, so that's, well, I think I labeled that E, but that would be FGH. That was example H. Sorry about that. Oh, I wanted to also point out, this one could have been approached a little differently as well. Let's see what that could have looked like. If I had taken, what if I had done this? What if I had taken my original sine squared x equals 3 times cosine squared x? What if I had divided both sides by cosine squared x here? So if I divide by cosine squared x on both sides, it's legal to do this because sine squared x over cosine squared x can be replaced with tangent squared x. Well, tangent squared x equals 3. So, not really sure why I put the square root of 3. My brain got ahead of me, but that should equal 3. So now if I think of this as tangent of x all squared equals 3, how do you undo the square? Take the square root, and here we have tangent of x equals both positive and negative square root of 3. And so if we go back over, if we just kind of look at the angle that we looked at earlier, tangent is sine over cosine. So sine over cosine would be the square root of 3 over 1, which is that. So x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay? So that was just 2 different approaches that we could take for example H. Okay, so let me look at the remaining examples and pick out one more to do. What if we look at, let's look at K, because K is going to be one where a U substitution, using a little substitution approach, might help us in solving this equation. Okay, so let's see. What did I say? K. All right, so here's K. Okay. So we have 2 times the sine of x over 2 equals 1. Now, let's take a look at what we have. X over 2, this is a half angle. And we did not look, in lesson 1, we did not focus on the half angles. And that's okay. We don't have to be able to solve this equation. Here's what I'm going to do. And this is a technique that we use a lot in calculus. I'm going to rewrite this equation in a little bit different form to make solving this a little easier. I'm going to let U, I could use something else. I could use P, I could use T, M, anything as long as it's not X. Excuse me. So I'm going to let U equal X over 2. And now I'm going to rewrite my equation. 2 times the sine of u equals 1. And so now this equation, if I solve this for u, I would go ahead and divide by 2, pardon me, and I have sine of u equals 1/2. Now let's look for the angle, or an angles, the family of angles where sine is 1/2. And so sine would be 1/2 here. And this angle is what, 30 degrees, so this is a pi over 6. So pi over 6 has a sine value of 1/2, and the other angle for pi over 6 would be in quadrant 2. So u equals, notice I said u, not x, but u equals pi over 6 and 5 pi over 6. Now, if I were to plug pi over 6 in for x into the original equation, I would not get a true statement. I would not get a value that solved that equation. And the reason why is because these two solutions are values of u. Well, I can now easily go back and replace u with x over 2. So I'm going to separate this. I have a u that equals pi over 6. I have a u that equals 5 pi over 6. So if I now go back in and replace u with x over 2 equals pi over 6, and if I replace u with x over 2 and set that equal to 5 pi over 6, all I have left to do now is if I solve these two little equations for x, I'll have my angles. So how do I get x by itself? Multiply both sides by 2. I get x equals 2 pi over 6, which reduces 2 pi over 3. And here x equals 10 pi over 6, which reduces to 5 pi over 3. Sorry, I went blank there for a minute. So x equals pi over 3 and x equals 5 pi over 3. And there are my solutions. So this is a scenario where we had this x over 2 business, and rewriting x over 2 in terms of something else to begin with made solving this equation a little easier, at least I hope. So that's the last of the examples that I want to go through. You can look at the other examples that I have worked out for you. And as always, please do not hesitate to reach out if you have any questions at all. I miss seeing you guys, by the way.